Good morning, my dear friends. See now, we shall go to the second problem now. Okay, I will read this problem. Investigate the design of a PSC section using Hin's method if MT is equal to 500 kilonewton meter and MD is equal to 330 kilonewton meter for the following. Okay, so he has given MT and he has given MD. Okay, and in sense now, first one he says preliminary design you have to do it, and next is trial design with no tension, in the sense when you are not allowing any tension in the concrete. Third one is trial design allowing the tension. Anyhow, this C is not there, only we are restricting to trial design with no tension. Okay, this case is not there for your this thing now. So he has given some data. Assume FCCI. Okay, you know that it is allowable compressive stress in concrete in initial condition 15 Newton per mm square, and FCCF allowable compressive stress in final condition 13 Newton per mm square, and FCTI and FCTF, in a sense allowable tensile stress in initial condition as well as in final condition, is now 1 Newton per mm square. Okay, FPI is equal to 960 Newton per mm square and FPE is equal to 800 Newton per mm square. Okay, so with this data you will have to start with. Okay, so now as usual, we will first go with the preliminary design now. Okay, so now since I know MD and MT, okay, so I will take the ratio of MD by MT. So if you take the ratio of MD by MT, it is 0.66. So it is now greater than 0.2 in sense now. Okay, so it is greater than 0.2. So I say that it is the it comes under large MD by MT ratio. Am I right now? So now, first of all, I will try to fix up the depth of the beam by using so many thumb rules, etc., etc. Okay. So one of the thumb rules says that depth can be calculated as D is equal to K under root MT, because this is MD by MT ratio is now greater than 0.2. Okay. So now, as I have already said you, K value varies from 30 to 40. So I have taken K is equal to 40. So D is equal to 40 into MT value, you know. Okay. So you will get 895 mm. Okay. So now, anyhow, I am going to assume the overall depth D is equal to 1000 mm instead of 895. Okay. That's one thing now. So now since MD by MT ratio is now greater than 0.2, the required effective pre-stress is given by. Okay, so you know this equation again. It is there in the preliminary design. PE, effective pre-stress PE, is given by MT divided by 0.65D. So MT I know, convert it into Newton mm. Okay, 0.65 D we have adopted as now 1000. Am I right now? So approximately I need an effective pre-stress of 769231 newtons. Okay, so now next step is, now I want to calculate the area of concrete AC. Okay, again for AC you have got one equation. It is PE divided by 0.5 FCCF. Okay, so PE I know because just now you have fixed the PE. Okay, and 0.5 into FCCF value, it is given in the problem. It is so much. So now you will get the value in sense now as 118343 mm square. This is the area of concrete I need. Okay, so now I want to calculate area of steel AP. Okay, area of steel, in sense pre-stressing area of pre-stressing steel area. Okay, it is given by effective pre-stress divided by safe stress in tendons, or FPE. FPE value is given in the problem. Okay, PE you know, PE value just now you have calculated, it is so much, divided by FPE value is 800. So it gives me 961.59 mm square. Okay, this is the area of steel you need, pre-stressing steel wires. Okay, so but now I will take a decision to provide a T section. I think in the last problem we have given an I section. now we shall take up one unsymmetrical section, T section. Okay. So now when I want to provide T section, but now again from your preliminary design, we know approximate thickness of the web. Thickness of the web is given by d by 40 plus 100. Okay, so d, you know, 1000 divided by 40 plus 100 will give me 125 mm. Okay, it is thickness of the web. So now accordingly I will go on explaining you here now. So I want to go for a T section. Am I right? The depth of the T section we have already fixed it up as 1000 mm, and now thickness of the web we have fixed it up as 125. Just now you know approximately it is 125. Okay, now approximate width of the flange, in the sense this width of the flange is, it is given by 0.5d. Okay, 0.5, depth is 1000, so it is approximately 500 mm. So now I am going to fix this flange width as 500 mm. Okay, so now approximate thickness of the flange, in the sense this thickness of the flange, it is given by 1/5 of d, so it will give me 200 mm. So approximately thickness is now fixed as 200 mm. So now almost I have fixed up all the dimensions of this T section. Okay, so now I think you can easily calculate the cross-sectional area provided. So it is the area of this flange plus area of this web. Am I right now? So I think you can easily calculate this. It will give me 2 lakh mm square. Okay, so now total area of this T section is now, it is 2 lakh. Okay, sir. Now see, now in a sense, this is, in sense I have provided an area of concrete as 2 lakhs. But it is a much greater than our required area AC. Just now you have seen area of concrete required is now 1 lakh 18,000. Am I right, sir? Now 1 lakh 18,000 it is. But I have given an area of 2 lakh. In the sense, I have given more area than the required AC. Am I right now? So therefore now I say that it is okay. Okay. Otherwise, see now. See now. Actually, you know that this area of 2 lakh given is very high. Required area is 1 lakh 18,000. But you have given how much now? 2 lakh. It seems it is very high. In sense, it may give rise to uneconomical section. So now even you can reduce the section. So slightly we shall reduce the section here now, so that it will become in sense of slightly greater than this value. Okay. So now I will modify the dimensions. See now, modified dimensions are shown here now. Okay, so now here instead of 500 I have given 400 mm, instead of 1000 mm 900 mm I have given. This also I have reduced it to 100 mm, and this also I have reduced it to 100 mm. Okay, so now I have reduced this cross sectional area. So now I think you can easily calculate this cross sectional area provided. Okay, it is the area of this flange, area of this web. Okay, so it will give me 1,20,000. Okay, 1,20,000 mm square is the area of this AC. Okay, so now you in sense of it is slightly greater than our AC required. Am I right now? So I say that it is okay now. In the sense, I have given slightly more area than the required. So now I say that this cross section is okay. So now this is all your preliminary design. Okay. Now we shall go to final design by allowing no tension in concrete. Am I right, sir? Now see now, but this we'll try to see it in the next class. Okay. Thank you.